All right, another example we have here for section 6.6 is about crickets here. When we have crickets are chirping 124 times per minute, it's about 68 degrees Fahrenheit, because there is a relationship between how many times crickets chirp and the temperature outside. It's actually a linear relationship between these two. That's what we're going to kind of talk about here. So when they chirp 124 times per minute, the temperature is about 68 degrees Fahrenheit. And when they chirp 172 times per minute, it's about 80 degrees Fahrenheit. And there's no question here, but the question is, write an equation that models the relationship between how many times a cricket chirps and the temperature in degrees Fahrenheit. So really what we have here is we have 2 points. And if we have 2 points, we can find the slope. One of the points that we're given is 124.68, because when a cricket chirps 124 times, it's 68 degrees. Another point that we're given is 172.80, because when a cricket chirps 172 times, it's about 80 degrees. With these 2 points, we can find the slope of the line that contains these 2 points. And we can do that by plugging these points in to our slope formula. So we will do 80 minus 68, 80 minus 68, divided by 172 minus 124. And by doing that, we get 12 over 48. 80 minus 68 is 12. 172 minus 124 is 48. That fraction can be reduced to 1/4. So the slope of the line that contains these 2 points that we got from the information that we were given about crickets and chirping is 1/4. That's the slope of the line that contains these 2 points. If we were to graph them, that line would have a slope of 1/4. So now that we have that slope, we're going to write this equation in slope-intercept form. And we do not have the y-intercept, but we are going to find the y-intercept. And we have a couple of pieces of information here. We have the slope that we found, it's 1/4. We also have a point that's on the line. A point that's on the line is 124.68. How do we know that's a point on the line? Because we were told that was a point on the line. We were told that when crickets chirp 124 times in a minute, it's 68 degrees. So this is a point, and now what we're going to do is we're going to take these values and plug them into this equation to solve for b, to solve for this y-intercept. So what I'm going to do is take those values and plug them in. The y value we have here is 68. So 68 is going to go plugged in for the y, and that's exactly what we have here. And then we have y equals m. The m is the 1/4, the slope that we found. The x value we have here is 124. That's right here. 124 is the x value. 68 is the y value. 1/4 is the m value. And then we have plus b. And now we can solve for b. So when we look at this equation, we have 1/4 times 124, or 124 divided by 4. And that simplifies to 31. Where does 31 come from? 31 is 1/4 times 124, or 124 divided by 4. So now we have 68 equals 31 plus b. And now we are going to solve for b by subtracting 31 on each side, and we get b is 37. So what this b means is that when crickets don't chirp at all, when the x is 0, y is 37. So when it's 0 degrees, or I'm sorry, when crickets don't chirp at all, it is 37 degrees. And then from there on out, below 37, they do not chirp. So now we have enough information to plug this into our slope-intercept form. We have the slope that we found, 1/4. We now have the y-intercept, the b, is 37. So if we plug these 2 values into our slope-intercept form, we get y equals 1/4 x plus 37. This is an equation that models how many times crickets chirp based on the degrees outside, or the degrees outside based on how many times the crickets chirp. We can plug in any number we want in for x, and that would be the number of times the cricket chirps in a minute, and that will give us the y value, which will be the temperature in degrees Fahrenheit.